Welcome back to Teddy Talks. In this video, we are going to show or we are going to incorporate all the knowledge that we gathered in the previous two videos about projectile motion and come up with an equation of a trajectory. And we know that an equation of a trajectory is a parabola. So now, at the end of this video, you should be knowing how does an equation of a parabola look like. Now let us go. Consider a body projected with an initial velocity u at an angle theta to the horizontal. So we're going to sketch what we've just said. This is our particle which is projected. Now, we are going to come up with the words that define what we are putting here. Now, the vertical distance to move from here up to there, we call it horizontal range. And this is the x-axis, of course. Y-axis. And this is the x-axis. This is the angle of projection. We are saying that this particle has a velocity u, and when it reaches the highest point, we call it maximum height. The highest point reached is called maximum height. Now, we are going to consider a particle at point A. Okay? We are going to consider a particle at point A. Now, when we look at a particle at point A, this particle of ours has two components of velocity. So we write and say that the particle has two components. The particle has two components of velocity. It has the horizontal component. And the vertical component. So this horizontal component in ux, and this is uy. Now let's look at the horizontal component. We know that for us to be in position to get the component of velocity at any time t, we should use the first equation of motion. Now, since it is horizontal, this is Vx u cos theta. Acceleration is 0 in horizontal component, in the horizontal direction. So let's look at the vertical component here also. We look at the vertical component here. The same expression v equaling to u plus at, we say that for vertical component uy is u sin theta. So it means our vy is u sin theta. Now our acceleration is negative g minus negative g. So this gives us the velocity of y at any point. Now, from here also, let's look at the displacement. Now, for displacement, we know that, again, still, this particle is covering both the horizontal displacement and the vertical displacement. Vertical displacement. It has two of them. It is going upwards, but also covering a distance in a horizontal direction. Now, when we are getting displacement, we said we use the second equation of motion, which said that S is equal to ut plus a half at squared. Now, in the x direction, in the horizontal direction, we call this distance x, and we say that the velocity ux is given by u cos theta. So this is u cos theta times t. But the acceleration, this side is 0, so this becomes 0, and we remain with this, so I can call this one my equation 1. Now, also, when we look at the vertical component, or I mean the vertical displacement, we know that displacement is given by the expression ut plus a half at squared, but this distance here can be given, I mean, this s can be written as y, and we said that for vertical displacement, uy is u sin theta, therefore this one becomes u sin theta times t minus a half, because g is negative, gt squared. We can call this equation 2. Now, when you look at the two equations we have, we see that from equation 1, time can be given or can be got from the expression x out of u cos theta. That is what it shows us. Now, if it is true from here that time is u out of cos theta, if I substitute for t, substituting for t in equation 1, I mean in equation 2, what do I get? I see that my y is equal to u sin theta times x out of u cos theta minus a half g into x out of u cos theta, but the whole of it squared. Now I realize that this u is the same as u sin theta out of u cos theta times x minus g, we open bracket, this is x squared out of 2 u squared cos theta squared u. But we know that from trigonometry, u sin theta out of u, even if u, I mean sin theta out of cos theta, this gives us tan theta, and the u goes with the u. Therefore, my expression here becomes that y is equal to x tan theta minus gx out of 2u squared cos theta squared. Now, we know this is the same as saying y is equal to x tan theta minus 1 out of cos theta squared times gx squared out of 2u squared. But also from math or from trigonometry, we know that 1 out of cos theta squared is the same as sec squared. Therefore, our expression becomes x tan theta minus gx squared times sec theta out of 2u squared. Now, here still, again also, from math, we know that sec squared theta is the same as 1 plus tan theta squared. Therefore, this tells me that my x is equal to tan theta minus gx squared times 1 plus tan theta squared all over 2u sin theta. Now, this is, we can say, let this be our final expression here, and maybe we call it star. Now, what observations do we get from star? Expression star is what we call an equation of a trajectory. So we can baptize it that this is an equation, this is the equation, of a trajectory, and it shows that the path taken by a projectile is a parabola or parabolic. Now, all these equations, even this is an equation of a trajectory, even this is an equation of a trajectory. Whichever equation you use there, you would get the same results. So all those equations, we realize that those equations, their nature shows that the path taken by a projectile is parabola, and therefore in an exam what you are asked to show that the path described by a projectile is parabolic, then you need to derive this expression.